Picture this. You are knocked out cold, mouth open, completely unaware of anything happening around you. In your bed? That is no big deal. Now move that same scene into a tent somewhere in the wild. One thin sheet of nylon between you and a forest full of things that could kill you without much effort. Wolves, leopards, bears, animals that can hear your pulse from yards away, smell you from much further than that, and see clearly in pitch darkness while your eyes are shut and your body has gone limp. And yet you wake up, every time, almost always. Stop and actually sit with how strange that is. A sleeping person is just a body. Soft, slow, defenseless, cannot run, cannot fight, barely registers a threat until it is already too late. You would expect campsites to be a nightly buffet line. They are not. They are almost never that. And the explanation is not one tidy fact. It is a stack of them, layered on top of each other. And once you see the whole stack, it starts to look like something close to an unspoken truce between humans and everything wild. A truce older than cities, older than farming, older than anything we would normally call human history. Let us get into it. This sounds like flattery, but it is just biology. You personally, right now, probably are not intimidating. But as a species, to a predator's nervous system, humans register as something close to a nightmare. Not because we look dangerous. We do not. No claws, not fast, not especially strong for our size, and our night vision is a joke compared to almost anything that hunts after dark. By the numbers, we are a pretty unimpressive animal. And yet, in 2019, researchers from UC Santa Cruz ran an experiment on mountain lions in the Santa Cruz Mountains. They played recordings, just ordinary human voices, people chatting, near the cats. The pumas bolted. Not occasionally, consistently, and at rates matching or exceeding how often they fled from recorded dog barks. These are animals capable of dragging a full-grown deer up a hillside. Apex hunters by any definition. And a conversation made them run. Here is the part that really lands it. Some of those mountain lions abandoned kills they were actively eating, mid-meal. Food they had already paid for in calories and risk, left on the ground the second a human voice showed up nearby. That is an enormous cost for a wild animal to absorb. Walking away from a kill means those burned calories never come back. They did it anyway. Because whatever instinct tells them to avoid us outweighs hunger itself. This is not isolated to California cougars either. Lions in South Africa's Kruger National Park noticeably cut their movement in zones with heavier human presence. Tigers across India rout around villages, even when those villages sit inside otherwise perfect tiger habitat. Jaguars in the Amazon have shifted their ranges to dodge areas where people show up regularly. None of these animals are physically incapable of confronting a human. They have simply, as a species over an enormous number of generations, concluded it is not worth it. And the reason behind that conclusion is brutal when you think it through. Humans have hunted large predators so long and so relentlessly that we have literally rewired their gene pool. We have been active hunters for roughly 2 million years. We hunted mammoths into extinction. We wiped out giant ground sloths, woolly rhinos, saber-toothed cats, cave bears, animals that had outlasted entire ice ages, gone within a few thousand years of humans showing up. In North America, we pushed wolves to the brink across the whole continent and erased mountain lions from the entire eastern half. We shot them, trapped them, poisoned them for so long and so thoroughly that the predators alive today descend specifically from the ones that knew to keep their distance. That is not poetic exaggeration. That is literal natural selection. The bold ones, the ones that wandered too close to human camps, got killed off. The cautious ones survived. They bred. They passed that caution down. Generation after generation, that wariness calcified into instinct. It is now baked into the baseline behavior of nearly every large predator sharing space with us. So when a leopard catches your scent at 2 in the morning, something old and wordless fires a warning. Not a conscious thought. A signal, inherited from every ancestor of that leopard who survived a close encounter with something upright and unpredictable. Stay back. Do not engage. Move on. Now think about your smell. You have probably never thought hard about your own scent because you are surrounded by people who smell roughly the same, and your nose stopped noticing decades ago. But to a predator whose sense of smell can outclass yours by a factor of 10 to over 100,000, depending on the species, you are putting out a chemical broadcast that is loud, dense, and frankly, bizarre. A bear's nose is estimated at something like 7 times more sensitive than a bloodhound's. Wolves can pick up certain scents from close to 2 miles out under the right wind conditions. Big cats carry a specialized structure called the Jacobson's organ that lets them essentially taste scent particles in the air, pulling chemical detail most of us cannot even imagine. When one of these animals comes across a sleeping person, it is getting hit with a flood of olfactory information. And a lot of it does not compute. You smell like synthetic tent fabric. You smell like the granola bar you ate at lunch. You smell like sunscreen, bug spray, shampoo, deodorant, a chemical cocktail with no equivalent anywhere in nature. Strip all that modern noise away, and underneath it, sure, you smell like a primate. Which is something, but it is not the thing. Not a deer, not a wildebeest, not anything a predator's hunting instinct has been calibrated against over millions of years of trial and error. That instinct is not a vague hunger switch. It is narrow and specific. A wolf's chase response triggers off the particular gait of hoofed animals. A lion's strike sequence fires based on the smell, shape, and movement pattern of prey it has encountered thousands of times across generations. You do not match the template. You are outside the system entirely. And things outside the system get caution, not appetite. Here is one of the smartest things our species ever stumbled into, possibly before we even understood why it worked. Fire produces something close to a universal fear response across land animals. Not learned. Not something a young animal has to figure out the hard way. Wired in from birth. The logic is simple. Animals that fled from fire survived wildfires. Animals that did not, did not. That fear runs so deep that lab animals with zero prior exposure to flame will still show avoidance behavior just from the smell of smoke. Humans have had fire for somewhere between 1 and 2 million years, and for almost all of that time, sleeping near a fire has been the default, not just for warmth, not just for cooking, because, intentionally or not, it functions as a deterrent. A campfire is not only heat and light, it is a signal broadcasting into the dark that says something here controls fire. Something here is best avoided. Predators got that message a long time ago, and they have gotten it for so many generations that it does not even register as a message anymore. It is just an automatic trigger for distance. Your ancestors figured this out before agriculture, before pottery, before writing, before architecture. Fire came first. Good instinct. Now let us correct something that movies have spent decades getting completely wrong. The apex predator is not a fearless killing machine that lunges at anything that moves. That is fiction. In reality, big predators are extraordinarily calculating about what they choose to engage, because they have no other option. A wolf does not get sick leave. A lion does not have a vet on call. A broken leg, a torn eye, a deep bite wound. Any of these can mean a slow death by starvation weeks later. There is no recovery room in the wild. You either heal while still somehow managing to hunt and eat, or you do not heal and you die, which means every potential target gets run through a survival cost calculation. Is this worth the risk of getting hurt? Do I actually understand how this thing behaves? Is the payoff big enough to justify the energy I am about to spend? A sleeping human fails that calculation on nearly every axis. First, unfamiliarity. Predators feel most confident attacking animals they have studied for generations. Prey whose blind spots and panic patterns and escape routes are practically encoded in their hunting strategy. They have none of that with us. We are erratic. We might wake up shouting. We might have tools nearby. We might have other humans close enough to respond fast. That unpredictability alone is enough to make most predators back off. Second, our size reads as a threat even when we are not trying to project one. Standing upright makes humans look considerably larger relative to our actual body weight than most prey animals our size. Researchers studying predator behavior have pointed out that bipedal posture itself functions like a built-in threat display, similar to a gorilla standing tall or a bear rearing up to look intimidating. We just walk around like that constantly, which reads as innate confidence to anything watching. Even curled up asleep, the human silhouette does not read as easy prey. Third, and maybe the simplest reason of all, why bother? A predator with an intact territory has plenty of familiar, lower-risk food sources nearby. Chasing something unfamiliar and possibly dangerous when there is a known, comfortable meal available just does not make sense. The math does not favor it. Here is a detail that almost never comes up in these conversations. And it should. Human sleep moves in cycles, dropping into deep, slow-wave stages and then rising back into lighter phases, including REM, where the brain stays surprisingly engaged. Researchers have found that during these lighter stages, your brain is still actively processing sound from the environment. Unfamiliar noises are far more likely to break through into conscious awareness than familiar background sound. This is sometimes called the sentinel function of sleep, the idea that even while resting, the brain keeps a partial watch running. A branch snapping too loudly, something heavy moving through brush nearby, a shift in air pressure that comes with a large animal approaching. These cues can pull you toward waking faster than you would expect. This is not a coincidence. Early humans who slept too deeply to register nighttime threats simply did not survive to pass that trait on. The lighter sleepers, the ones who could go from unconscious to upright in seconds, were the ones who lived long enough to reproduce. Across hundreds of thousands of years, that selection pressure tuned human sleep toward staying responsive. We sleep in shorter, lighter cycles than most large mammals, because our evolutionary history assumed there would always be something in the dark worth waking up for. So, while unconsciousness feels like total vulnerability, you are actually running a fairly capable early warning system the entire time you are out. And then there is the group. People almost never camp completely alone, and predators understand group dynamics at an instinctive level because their usual prey also moves in groups. A wildebeest at the center of a herd is far safer than one caught at the edge. A fish in the middle of a school is much harder to pick off than one swimming solo. Predators do not just attack whatever is nearby, they hunt for separation. The isolated one, the one that has fallen behind, the one cut off from support. A sleeping camp full of people is a group. And not just any group. One where a single person waking up and making noise is likely to wake several others fast. That collective response is exactly the kind of unpredictable, high-risk scenario predators are evolved to steer around. A clean, quiet kill turning into a chaotic group defense is the worst outcome from a hunting calculation standpoint. Predators tend to avoid situations that could spiral that way. Now, none of this means you are untouchable. It would be irresponsible to pretend otherwise. The attacks that do happen follow a pattern, almost always the same pattern. An injured predator that can no longer hunt its normal prey. A starving one whose habitat and food sources have collapsed. A predator that has lost its inherited caution through repeated safe contact with humans. Or simply an old animal past its physical prime, no longer fast enough to catch what it used to. The Tsavo lions are the textbook case. In 1898, 2 male lions killed railway workers in Kenya over roughly 9 months. The exact number is still debated, with earlier colonial accounts inflating the figures significantly. What is often left out of the legend is that these were unusual lions, mannerless, which is itself atypical, and at least one had serious dental damage that would have made hunting normal prey far harder. The Champawat tiger, blamed for hundreds of deaths across Nepal and India in the early 1900s, was eventually tracked down by hunter Jim Corbett, who found it had been shot in the jaw at some earlier point, shattering 2 canine teeth. Unable to hunt its natural prey effectively, pushed further by shrinking habitat, it turned to the only consistently available prey left. That pattern repeats across almost every documented case. Something broke first. The normal calculation got scrambled. Desperation overrode the inherited instinct to stay away, which means the general rule holds remarkably well wherever the ecosystem is intact, the predator is healthy, and humans have not done something to scramble the usual signals. Here is the part that genuinely reframes the whole thing. We have made the natural world so afraid of us that it is now creating consequences we never planned for. That same UC Santa Cruz Puma study did not stop at documenting fear. It traced how that fear ripples through the entire food web in ways that are hard to fully predict or control. When pumas avoid human-heavy zones, deer in those zones face less predation. Deer numbers climb. More deer means more overgrazing of local vegetation. Meanwhile, mid-sized predators, coyotes, bobcats, foxes, also pull back from areas with human activity, which means the rodent populations they would normally keep in check start expanding unchecked. The whole system shifts, layer by layer, because of us. Because the fear we have cultivated over thousands of years radiates outward like a signal, changing the behavior of predators across entire continents, most of which we will never directly encounter, just by being the thing evolution taught them to avoid. One inherited fear, rippling through an entire living world. The most dangerous animal on this planet is the one that figured out fire before it figured out almost anything else. The one that has been reshaping ecosystems not just through what it eats, but through what it makes everything else too afraid to eat. The one that sleeps light, moves in groups, and carries tens of thousands of generations of successful survival written into its instincts. That is you. So next time you are zipped into a tent somewhere remote, listening to whatever is moving around out there in the dark, and you feel that small, ancient flicker of unease, let it be there. That feeling kept your ancestors alive. But the thing outside the tent is not coming in. It already knows better.